Hello everyone, welcome to this new video from Guidancee Education channel. We are continuing class 12 physics chapter 2 electrostatic potential and capacitance. We have already derived expressions for calculating effective capacitance when capacitors are connected in series and parallel. If you have not watched those videos, go to playlist and watch those videos because in this video we are going to solve problems related to combination of capacitors. So if you understand those basic points, it will be easy for you to understand solving such problems. I have given the link of one video in the I button. You may click that and watch that. I have given one combination of capacitors in the picture and related problem below that. This circuit diagram looks very complicated and you might think it is very difficult to solve these problems. But we will work on that and reduce it and simplify it so that we can easily do the problem. But before we start solving the problem, please watch the video thoroughly well so that you get all points cleared. Such problems are asked for the examination. You should not lose any marks there. If you think the video is useful, do not forget to like, share and comment on the video. If you have not yet subscribed my channel, do subscribe it now. Press the bell button and all button for notification of more videos like this. I am Ananthavalli. Come, let us start the class. The combination above is connected to 100 volt battery. Calculate the effective capacitance and the total charge. That is the question. Let us mark point A and point B on the diagram. Let the potential difference at point A be equal to V and that on B be equal to V dash. In the diagram we find there are various points where there is more than one path. Look at this point. There are two paths, one downward and one towards the right. Similarly, there are three such points where you find two paths. Please understand that from diagram. First, we have to see the potential, that is potential difference at these points where there are more than one path. What is the trick that we apply there? Between 2 points, if there are no other elements connected, then the potential difference will be the same. In case any element is connected there, then the potential difference will change. At point B, the potential is V dash. From B to the next point, there are no further elements connected there. So, the potential at this point will be V dash only. Now, at this point also, in between, there is no further elements connected. So, there also it will be V dash. At point A, the potential is V. That is, potential difference is V. At this junction, in between, there is one capacitor. So, the potential will change at this point. Let it be V1. Between this point and this point, there is no interruption. So, the potential at this point also will be V1. So, in the whole circuit, we find there is possibility of three different potentials. One at A, then at this point V1. From V1, there are three paths. Path 1, 2 and 3. And down you find at three different points you have the same potential V dash. Please do not confuse between V1 and V dash. We will represent these potentials V, V1 and V dash separately. In the given problem, between V and V1, there is one capacitor. The capacitance is 40 microfarad. We will make a representation of that capacitor. From V1, we find there are three paths. We have to see the different capacitors there and represent them. They are between V1 and V dash. We will first represent these two capacitors. 10 microfarad each. That is done now. See that? In the third path between V1 and V dash, there are three capacitors of capacitance 60 microfarad each. We will represent that. We will also mark point A and B and note the capacitance. We have actually rearranged the circuit. So this circuit now looks rather simple. The last three capacitors in the third path having capacitance 60 microfarad each is in series. Let us number the capacitors C1, C2, C3, C4, C5 and C6. Verify this number with the circuit that is given in the problem. There also you find 6 capacitors. The effective capacitance 1 by Cs for capacitors 4, 5 and 6 is equal to 1 by C1 plus 1 by C2 plus 1 by C3, that is equal to 1 by C4 plus 1 by C5 plus 1 by C6. Substituting, that will be equal to 1 upon 60 microfarad plus 1 upon 60 microfarad plus 1 upon 60 microfarad, which is equal to 3 upon 60 microfarad equal to 1 by 20 microfarad. So, the effective capacitance in series for 4, 5 and 6 is equal to 20 microfarad. Now, this circuit can be redrawn by replacing capacitors 4, 5 and 6 by an equivalent capacitance of 20 microfarad. Now, we will redraw that. We will draw the diagram. This is V, V1 and V dash. These are the points A and B. This is the capacitor between V and V1. Capacitance 40 microfarad. Capacitor C1. Between V1 and V dash we have to show three capacitors now. Capacitor C2 and capacitor C3 with capacitance 10 microfarad each. Then one more capacitor equivalent to C4, C5 and C6 with equivalent capacitance 20 microfarad. Between V1 and V dash, the circuit has become very simple. We have the capacitors C2, C3 and the equivalent capacitance for C4, C5 and C6 in parallel connection. We will note the equivalent capacitance 20 microfarad as C dash. So we can easily find the equivalent capacitance for these three capacitors. Cp is equal to C2 plus C3 plus equivalent capacitance for C4, 5 and 6. So substituting for C2, C3 and C dash, we get Cp is equal to 10 microfarad plus 10 microfarad plus 20 microfarad, which is equal to 40 microfarad. So, we can represent these three capacitors between V1 and V dash by a single equivalent capacitor with capacitance 40 microfarad. So, the circuit can be further simplified as between V and V1, there is one capacitor C1 with 40 microfarad capacitance, and between V1 and V dash there is only a single capacitor with effective capacitance of 40 microfarad. So we will make a representation of that. There is one more capacitor with the effective capacitance of 40 microfarad. All these three capacitors between V1 and V dash is reduced to one capacitor. Now the two capacitors are between V and V dash. This capacitor is equivalent to 2, 3, 4, 5 and 6. Now these two capacitors are again in series. Effective capacitance Cs for these two capacitors will be 1 upon Cs is equal to 1 upon 40 microfarad plus 1 upon 40 microfarad equal to 2 upon 40 microfarad, which is equivalent to 1 upon 20 microfarad. So finally we have this effective capacitance for this whole circuit, which is equal to Cs is equal to 20 microfarad. So we will note the answer for the first section. Effective capacitance C effective is equal to 20 microfarad. The problem says this circuit is connected to a 100-volt battery. We have to find out the total charge. So we will draw a diagram for that. This is the capacitor with effective capacitance equal to 20 microfarad connected to the battery of 100 volt. That is, potential difference of the battery is 100 volts. We have to calculate the total charge. Effective capacitance we have already calculated. What is the total charge Q? Q is equal to C multiplied by V. So we have to multiply this effective capacitance with voltage, that is 100 volts. So this gives, we will convert this effective capacitance into farad. So 20 into 10 raised to minus 6 farad multiplied by 100. That will give 2 into 10 raised to minus 3 coulomb. So we have calculated Q also. So the two things that are asked in the problem we have done. Q is equal to 2 into 10 raised to minus 3 coulomb. There is one zero in 20 and two zeros in 100. That is how we got 10 raised to minus 3. Okay. I will note there the magnitude of Q. We will just recall the steps that we followed. First, we allotted voltage at points where there are more than one path. Then we rearranged the capacitors accordingly and simplified the circuit. So based on whether you got the capacitors in series or in parallel, we used the concerned formula and went on calculating the effective capacitance for the capacitors part by part. Then we arrived at the final answer. I hope it is quite clear for you. If I was able to help you, please support me by your subscriptions, likes, comments, and shares. Please press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important problem like this. Till then, bye. Take care.